Assalamu alaikum dear students, we're back with another video lesson. In the previous video lesson, we were talking about motors. Motors are machines that convert electrical energy into mechanical energy. Of course, you need to connect the shaft so that this rotation can be converted to something useful. And then we also talked about the back EMF. Back EMF would be created, and it is generated when the coil of a motor is rotating inside a magnetic field. As a result of that, back EMF will be induced. In back EMF, it is always opposite to the applied voltage. And in order to know how much voltage is available on the coil, we'll use something like an equation. We can say the voltage applied minus or subtracted by the voltage or the back EMF, and then we get the voltage available or EMF available on the coil. And of course, the faster the rotation, the bigger the back EMF would become, which means that the EMF available and the current that is flowing through the coil would be less and less as the coil rotates faster and faster. Back EMF go through the beaten. Today we'll talk about a new concept where you can say the fifth method of inducing EMF, and that is by using mutual induction. What is mutual induction? We'll talk about this today, Basha, and mutual inductance. So first of all, we have two coils, as you can see here, Basha. So as you can see that, or we can start with the definition. We can say mutual induction is the ability of one circuit, Basha, to induce an EMF bubbling in the nearby circuit as a result of changing current. In the presence of changing current, we can say, what exactly is this here? So for example, we have a coil, Basha. This coil, as you can see, let's say this is too much. Let's just make this one a little bit less, Basha. So we have a coil. This coil, as you can see, that we have a switch and a battery. At this side here, there's an iron core here. You can say that, Basha. And then there is another coil at the other side here. And then you could say there is a light bulb, there's a galvanometer, doesn't matter. You can have a light bulb or a galvanometer, doesn't matter at this point here, Basha. So now, what exactly do you have? This is a battery that provides voltage, and this is a switch that you can turn on and off the circuit here. This coil here, it has a certain number of N. You can call that primary coil, Basha. Primary coil. You can call the other side secondary coil. Secondary coil, Basha. So what exactly happens once you close the switch? The moment you close the switch, now current starts to flow through the circuit, right? So the magnetic field strength around this coil, it is going to increase or grow up, right? So as the magnetic field is increasing, that means there's a change in flux, right? And this happens as a result of change current. When previously there was no current in a coil, but now once you close the circuit, the current starts to change. So now that change in current leads to a change in flux. That change in flux, we can say that it will be transferred, or this magnetic field will be transferred by this iron core here, to the other coil, Basha. And now we can see that there is a change in the flux on the other coil here. That leads to bubbling an EMF and a current in the other coil. So you can see that this galvanometer needle now, it is going to shift, we can say, to one of the side in here, Basha. So let's say the galvanometer needle is now going to shift to one side, Basha. But then, soon after you see that, for example, the galvanometer needle, it is going to get back to zero. So this change, once you close the switch, but when this change happened in a fraction of a second, maybe obviously less than a second, right? So as soon as the magnetic field start to form, magnetic field, there is no change in a magnetic flux anymore. There's no induced EMF on the other coil or in the primary coil. Basha, that is when we open, bubbling, close the switch. What happened when you open the switch? Now the magnetic field, you can see that starts to fade away or start to decrease more and more, because clearly there's no more current here. This is how it goes. When does this happen? Once you open the switch, there is again a change in, we can say, current. There's a change in flux, But Gutman, the first time, Baba, let me not forget this. Gutman, once you close the switch, magnetic field starts to grow. This increasing in magnetic field has the same effect as if we move a magnet close, Basha, to, let's just do it this way. It has the same effect as if we move a magnet close to a coil, because now at this point, Gutman, the number of magnetic field line that are, for example, cutting through this coil increases. That is first time, first try. Now, once we turn the switch off or open the switch, this one is the same effect as if we move the magnet away. So if you move the magnet away, magnetic field is that is obviously over this coil that is going to decrease because the magnet is moving away. So these two has the same effect. In either cases, there's a change in flux. That change in flux induces EMF and a current here. أوقات دوباره Gutman, the galvanometer needle is shifting, but this time it is going to shift, Basha, it is going to shift to the other side because now the direction bubbling of the magnetic field or the magnetic field is decreasing, which is opposite to what it was before, Basha. But once again, Gutman, this might happen in a second or less so, Basha, Kata, it does not happen. If you want to keep or continuously induce EMF on the other side, you have to keep turning the switch on and off continuously. So, and of course, this is very difficult to do that manually, just to keep bubble and turn the switch on and off automatically, like continuously. We can't do that. So, magnetic field we can replace this battery, which is a DC obviously, with something like an AC source. Magnetic field because if it is AC, both the magnitude will change and also the direction as well. You can continuously induce EMF on the other side, and this thing that will be induced here is going to be the same as the other one here. But this voltage, this EMF that is induced, by the way, it can be one of the this process is called mutual inductance. Basha, who was the scientist who did this? It was Faraday who first, for example, demonstrated this electromagnetic induction. To provide a magnetic field for this coil instead of just using a magnet closer, let's say bring a magnet close to the coil or away from a coil. And this process is called mutual inductance, mutual induction between two coils. It happens between two coils. Basha kaka, awad labirbi. Point shadikasham davis birum too. Maybe once I remember. So Gutman is that. Yes. Gutman, if we want Gutman EMF درز دبی بابا Gutman طبعا أو EMF كالير درز دبی توانی زیادو کمی که by changing the number of turns of this coil here, which is going to be studied. The twine blend. This is the base of a very important electrical device that is called transformer, which is going to be studied later. أو دبی تبيسي زیازه چیزوزو گرینگ لکاربای دیخین بابا, which is later. It's called transformer باشا. كايشة چیزوزو گرینگ بان لو دكاتن. We'll study that later inshallah. For now, Baba, got my later EMF درز دبی, but what is exactly or how much EMF will be induced? تونا بلن أو EMF درز دبی بابا. Like EMF2, that would be for secondary coil. The negative. تونا بلن M change in flux over delta time. Got my our E. We can call that the flux will be changing. And all this, of course, you could say this is going to be for the what is it called? For the secondary coil here, Basha. Because got my later current magnetic field line of course is going to increase whether it is increasing or decreasing. Got my iron magnetic field line we transfer the to the other coil. There is a change in a magnetic flux on this coil over a period of time and over some time that induces an EMF. This one here we can say it is equal to negative M. But man, why the magnetic flux over this coil change? Because the current on this coil change. دالنکه کرنت لسر کویله بگوره با magnetic field أو magnetic field أو کویله زیادو کم دکاتن لانزامی گورانی کرنت که ونیا أو جا magnetic field will be transferred to the other side. کاتا this change happen as a result of changing current over time bubbling in the first coil here. Basha. Now we can rewrite this one. The only equation that you need to know at this point, we can say EMF dakata. You could just write this one negative M delta I over delta T. Basha. This is the EMF induced, which is measured in volt. This is called the coefficient of mutual inductance measured in Henry, the same as coefficient of self-induction, by the way. There we called it L. Here it is for mutual inductance, it is M, but it is measured, it is measured in Henry again. Gotcha? There is current measured in ampere, or time measured in second. Got 20 mutual inductance and coefficient of mutual inductance بك subject بابا تاني بلن M دكاتا negative EMF باشا negative EMF لسر شي بابا تاني بلن لسر change in current يعني بابا the rate of change of current that is going to be delta I over delta T. هاد بسارك باسي mutual inductance كد أو كاتي this is the equation that you can use باشا equation شي زور أسانا تنها equation بكارديني أقر حز لبي ما كيف subject بانو عيا ودشكري مثلا it's possible that, for example, that you could possibly need to use these two equations. Never been in وزاري بس أقدر تنها لرحالة كاتب بابا أقال لي بي دتواني أدو equation equalize كيف زاو كاتي هاشتاج أنه نبود دتواني بيبينيو. So I don't think it's a big deal. But the most important part is this part. Kata, what is mutual inductance baba? It is what is it called, Wrya? The ability of one circuit, Basha, to induce EMF in the nearby circuit. Basha, the ability of one circuit to induce EMF in the nearby circuit by the changing of what? As a result of changing in current of this coil here. As the current change in this coil, that change in current leads to an EMF to be induced in this coil. Oh, ده تواني بلين بكتب بمختصري mutual inductance. بس ليه ربابي يقدوشت هي زوزو جرينجا ده تواني بلين what does mutual inductance depends on كاكا depends on two things باشا. يا كمان ده تواني بلين depends on the geometrical property of the coils باشا. كمان the number turn كانوا for example the number of turn on the medium of the two coils are and all that, and also we can say the orientation of the two coils as well. Like how are they put together? When you the orientation baba and do if the two coils are placed, let's say here's the this is clearly the iron core, we can say if the two coils are placed like this, we can see that the two coils are parallel to one another. If these two coils are parallel to one another, we get maximum EMF that is induced between the two coils, Basha. But if the two coils are placed, at a right angle to one another, for example, this is one of them, OED is placed like this, you can see that the angle between the two is 90, Basha. We get minimum EMF between the two, Basha, or you can say zero EMF between the two, Basha. أوقات دي بيت minimum يعني you can call that zero EMF. والذكري مثلا الذكري كويلك إيش اللي رد أبني أسايا المهم the angle between the two is 90, then whichever you write that will be totally fine. كواتات تواني coefficient mutual induction يبقى depends on two things: the geometrical property of the two coils and also the orientation of the two coils. يعني دو كويلك like how are they put يعني كويلك جديد عن رأينا. Mutual inductance Baba is the ability of one circuit to induce EMF in the nearby circuit in the presence of change in current. diagram كبونو هيا باتريك مان هيا switch مان هيا وش دو كويلة كي كويلة سرتها كويلة now there's a galvanometer to see if EMF is induced. يكم زار يكم كسشي بوشتيك بابا. It was demonstrated by Michael Faraday, or just Faraday, you can say that. He's the coil connected to a switch and a battery instead of a magnet, going to produce a magnetic field. This coil is called the primary coil. The magnetic field it is strengthened it is basically transfers the magnetic field of one coil to the other one, and the magnetic field it transfers the magnetic field of this coil into the other one beside making it stronger. A second coil is wrapped around the other or another part of the iron ring, and that is with a galvanometer. That would be the secondary coil. When the magnetic field of the primary coil is changed, EMF induced in the secondary. When the switch of the primary is closed, by the way, the galvanometer in the secondary circuit shifts to the right and then go back to the other side, because as you turn the switch on, the magnetic field change until it fully gets grown around the coil. Magnetic field but there's no change in the magnetic field anymore. There's no EMF in the other coil anymore. as long as the magnetic field is changing in the primary coil, EMF in the secondary coil will be induced. When the magnetic field starts, like for example, it doesn't change anymore, أوقات no EMF will be induced. كاتا لو حالتي بابا قرب هاتريك ما نهبو بونوعي تكاتك magnetic field كده جورا تنها لو حالتي كاسي تسكي دكينو ينداي دخين باشا. Good man. Once we close the switch, currents start to flow. Magnetic field دكيس يادي. Once we open the switch, so it's okay دكيوا باشا. أوقات no current will flow. Then the magnetic field start to decrease. لو دو حالتين magnetic field لك decrease دي ودكي رياستات تشيش بيني بكيف وقت كرنت كي زيادة كم كي أوقات إيش عسايا EMF كدرس تبيتين لك ولا كي باشا. When the switch is in the primary Goodman circuit closed, the galvanometer in the secondary circuit deflects in one direction and then returns to zero. And then when the switch is open, dubara the galvanometer deflects, but this time in opposite direction, then back to zero again. Goodman, when there is a steady current, in the primary circuit, the galvanometer needle reads the galvanometer reads zero, which means that there is no change in the flux, no change in no EMF induced. The magnitude of the EMF is predicted by Faraday's law of electromagnetic induction. An EMF and the induced EMF in the secondary coil, the negative N2 of the secondary coil, change in flux over time, negative akash baba obapiya silence bugutman basha, kadakata negative M, which is coefficient of mutual inductance, change in current over time in the primary coil, agad kata gutman, where M is the mutual inductance of the two coil measured in Henry, agad levi gutman. What does it depend on, baba? Depends on two things, basha, agad levi the geometrical property of the two coils, like their size, their shape, the number of turns, etc. And then the orientation of the two coil to each other. Parallel we get maximum EMF induced, basha, but if they are perpendicular, then we get minimum or zero EMF induced. This principle, baba, this would be, this mutual inductance would be the base of something very important in electricity, and that is called transformers. secondary coil and inducible, we can increase that or decrease that, and of course that's such a big thing, and that will be studied, of course, in transformers, inshallah. Basha, kata, these are basically a transformer. Basha, we have two coils and there's an iron core. We can increase or decrease the voltage using the transformer. Kata, what is the working principle of a transformer? We can say it is mutual induction. mutual induction subject kata negative EMF or negative equation changing current and the rate of changing current divided delta I over delta T. And you can define that as well. You could say it is the ratio of the induced EMF in the secondary to the rate of change of current in the primary coil. I said, describe how mutual induction occur, Baba. But man, how do we create how does mutual induction occur? But man, when the current change in the primary coil, that change changes the flux, the magnetic field around the coil, or change the flux, which is the number of magnetic field lines that are crossing the other coil. That flux or change in flux leads to an induced EMF in the other coil here. And that is basically mutual induction, obviously. Mutual induction occurs when there's a changing current in one coil. We call that primary coil, creates a changing magnetic field, which then, of course, induces an EMF in the nearby coil. You can call that the secondary coil without a direct contact between the two. I forgot perhaps to mention this. Remember, these two coils are not in contact with one another whatsoever. Direct connection between the two coils. These are not connected. Basha, this iron core between the two, it is only helping them to transfer the magnetic field efficiently or easily from one coil to the other one. حتى EMF كيدرس دبي باش تدرس بيتم. وكبسارة شد بابد تواني بلن بسارة شيل السرة بسارة كان زوجة كمان بسارة كاتك باسي mutual induction كرت أو كاتي only have one equation to use. باشا بسارة كمان سيليرها طلع a pair of adjacent coils باشا بسارة كزوجة راسانة وبسارة بيكو حلقين باشا هر كاتك قوتي a pair of adjacent coil يعني دو coil مان هي باشا a pair يعني جوتك باشا a pair of adjacent coils has a mutual inductance of on that kata M. Come on here. What is the value for M? It is 1.06 Henry. Don't forget. The next thing says determine the average EMF induced in the secondary coil, Basha, when the current in the primary changes from 0 to 9 in a 9.5 ampere in a time of the bubble in a time interval of this much. Kata current go from 0, that would be I1, to I2, which is 9.5 or 50 ampere in a time that is equal to 0.0336 seconds, Basha. 0.0336 seconds. Now all you have to do just write the equation here. Good man. EMF, Basha, that is induced the negative M change in current over delta T. Very simple. EMF good man negative M كمان سنة. It is 1.06 times change in current. That would be I2 minus I1 divided by delta T. So now you could just put the number or plug in the numbers. Man I2 gets in that is 9.5. I1 it is 0. Divided by the delta term, which is 0.336. You just do the math, you can find the EMF induced, right, which is going to be, or it is equal to negative 300 volts, and that's it. Pretty simple. عندك برسالة دي كمان هي بقى برسالة وزاري. Let's say the ability of one circuit to induce an EMF in the nearby circuit in the presence of changing current, Basha. The ability of one circuit to induce an EMF in the nearby circuit, you can consider this as a keyword. That would be self-induction, no. Mutual inductance, yes. Photoelectric effect, no. Inductive impedance, these are no. The symbol of M in this equation, all right, what does it represent? Gutman data. Is it a mass? Obviously not. Is it mutual inductance? Yes. Is it magnetic permeability? No. Coefficient of friction, that is also. Now, what about mutual induction and bubbling inductance between two coils? Depends on what Gutman depends only on the geometrical property? No. Depends only on the orientation of the two coils? No. Both the geometric properties of the two coils and their orientation to each other, that would be the correct answer. D says none of them, that is incorrect. Here you can see that is a copy paste of what we have. That is very recent. You can see only the time is changed. You can see that the numbers are changed, but that is pretty much pretty easy. It says the J bubble in a pair of adjacent. Whenever you hear pair of, that is obviously mutual inductance. And the Tony Blin Persarican Zozora Sana Shtachiwaiti Dania. Zorbash section review 6.2. We have a few questions, by the way. We've solved questions like this before, but right, since we'll just go through these questions just in case if you want to know how they're solved. باشا قرنا يتفكرت شنو دانيا بس بخوان حل دكينا زور باشا برسالي كمان ضل a loop with 37 turns قاعد ذيبي أو إجمالي turn كان you can call that n باشا and an area of onda يشمل here rotating this much radian per second, that is omega. The loop's axis of rotation is perpendicular to uniform magnetic field with the strength of onda or HB. What is the maximum EMF induced here? How can I get maximum EMF induced? Omega obviously this is for a generator. When you got the EMF and maximum EMF the maximum EMF maxaka the kata nabu when you sign kinanushin gutman later in a command 37 basha area command it is 0.33 times basha magnetic field command sanda it is 0.35 Tesla times omega command it is 281 radian per second. What if this was not in radian per second? What if it was degrees per second? Aukati, you should have changed that to radian per second and then you would have used the number. Possible on yeah. Now all you have to do is just do the math and you can find the answer. It's going to be this much volt on yeah. 120 volt. And that's I think it's pretty simple one yeah. Now stop the generator. A generator coil, 25 turns and a cross-sectional area of onda. I got no cross-sectional bibabe. There's a centimeter. Har katak centimeter square tabu bk yan bite bk matter just multiply by 10 to the power -4 or the beta meter squared. Area it is or has to be squared basha meter squared. The maximum EMF developed or the maximum EMF man here بس ليرة لجاتي اوميجا تي دايني بابا frequency دايني بسارك دلا what is the strength of a magnetic field كاتا ليرة بسارك عسانا باشا عينا equation دتوان بلن maximum دكاتا نبو NAB اوميجا بس لجاتي اوميجا frequency دايني كاتا دلين 2 pi f ونيا بسارك دلين magnetic field strength كيت سندا ديك subject دبيتا E max لصار NA 2 pi f استاك all you have to do just plug in the numbers later got my maximum EMF كيتسندا you can see that this says maximum EMF developed is 2.8 divided by جمارة هنا كان 25 area aka that is 36 times 10 to the power negative 4 أقال له 4 يبقى got man تدي كشمان هي got man 2 times 2 pi frequency كيتسندا 60 you just do the math you will find the answer which is going to be 0.083 Tesla زموش اشتشيواتي دانية زوزو راسانا 0.083 Tesla because it is a magnetic field باشا as you can see here اشتشيواتي جيتي دانية سيدي كشمانة بابا بسادي سام they'll explain what would happen if a commutator were not used in a motor باشتري باس مانكي قطمان the main job of a commutator in motors is to reverse the direction of a current so that the coil will rotate only in one direction. The coil will rotate half a cycle forward and half a cycle backward because the direction of the current will not be reversed. If that is the case here, so for example, if that was the case, if this is the case, because the coil is rotating for half a cycle is positive, half cycle is negative, for half a cycle is rotating forward because the direction of the current will be reversed, it rotates backward in this case it will not rotate in one direction, it does not work. Once again, without a commutator, a motor's current wouldn't be reversed, causing a misaligned magnetic field and preventing a continuous torque and continuous rotation, resulting in erratic or halted movement, like a shaky, almost like a vibration movement. Something when it moves back and forth real quick, it becomes sort of like a vibration. That is what is erratic or halt movement means here. Critical thinking. Suppose that a fixed distance separates the centers of two circular loops. Basha, what relative orientation of the loops will give the maximum mutual inductions. If they are parallel, we get maximum EMF. If they are perpendicular, we get minimum. If you place them parallel to one another, what orientation will give minimum mutual induction if the two coils are perpendicular to one another? And by the way, that would be the end of this section here. Now, I would like to remind you what we've studied so far. Good man, up to this point, Baba, we've studied 5 methods of inducing EMF. Basha, what was, as you can see here, Baba, what you see is a recap of what you have studied so far. The first method that, Babalin, ways and methods of inducing, Basha, ways of inducing EMF. The first method was using a wire. Good man, if a wire or a piece of conductor is moved inside a magnetic field at right angle locati, EMF which is equal to what? Equal to BLV was sine theta. Good man, the beta positive the beta negative, right? That is when we move a wire, good man, inside a magnetic field. That's what it is. And then after that, we were using let's say Faraday's law of electromagnetic induction. When a magnet, Basha, is moved close to, Basha, let's say a coil. Of course, then this EMF, or there would be a current, an EMF would be induced inside this coil. So as this magnet is getting closer or away from this coil, then EMF will be induced here. Negative and change in flux, or you can say change in AB cosine theta divided by delta T is, as long as the area or the magnetic field is changing, EMF will be induced, and that is called Faraday's law of electromagnetic induction, Baba. when we have one coil, but static will use this equation agar gutman magnetic field can area kabugora. And then we also learned about self-induction when gutman if a current in a coil change when let's say here's a battery by using a rheostat. I'll just draw this a bit nicer perhaps. And if I have a variable resistor, if you change the direction of the current in this coil here, as a result of this changing gutman magnetic field category, as a result of that change in a magnetic field gutman EMF that calls self-induction. When gutman this self-induction, it is basically equal to negative gutman L change in current over delta T. When gutman I got Levi Baba. When do we use, once again, this is also one coil as well. When do we use this? اگر gutman current kabgora basha increase or decrease katan wa agar pisara kibasi coefficient to self-induction kredibu whether if it is given or required. That was the third method. What about the fourth method, gutman? Fourth method, it was for a generator, gutman. Once a coil rotates inside a magnetic field, in two poles of a magnetic field, and then if it is rotating awkati gutman EMF debitan basha this EMF that is induced here for generator gutman, it becomes what? It becomes NAB omega sine omega t. When gutman, if we want to find maximum EMF dakata, maximum EMF dakata nabu NAB omega يعني جلتوان لذاتي omega بلاي 2 pi f. That is the fourth method. The last method was this method that we studied in this lesson gutman. It is for mutual induction. Mutual induction, then we can use this equation, the blend EMF that is induced dakata negative M for mutual induction, coefficient of mutual inductance, dakata change in current, basha. Let's write this one nicer so nobody says is that negative or not. The beta delta I over delta T, basha. That is the fifth method. These are all the methods we can say for section 2 that actually for section 1 and 2 that we could use to induce EMF basha. لا هر حالة أجر قوتي EMF كي ببينه دتواني بونو أي ببينه أجر الدنيا لهر يقلو method أنا قوتي current كي ببينه بابا أو كاتي قوت معنا أجر resistance دراوي عندها كراوي you can use Ohm's law سكهم جاري Ohm's law بابلان resistance يعني or دكاتة EMF لسر current أو زي for example once you find EMF. Of course, if you're required to find the current, so that you can cross multiply, you can find the current that is induced, the EMF that you just found, for example, divide by the resistance, you can find the current. These are the equations that we are required to know the most. I believe nothing more than that. Basha, if you get these equations, if you know what are the situations, then you will know what equation to use. It wouldn't become this scary, basha. And with a lot of practice, of course, it becomes something very useful. Basha, now let's jump into the next session, but I'll have to check the time one more time just to see if we have enough time to go through or to start the new section, basha. These are a recap, basha, of all the methods of inducing EMF with a little bit detail and bubbling note. Like when to use each one of these equations. I believe it is best to save this for the next lesson. Alright, so that'll be the end for this session. Keep practicing and I'll see you soon inshallah. Assalamu alaikum wa rahmatullah.